So we're going to start looking at trig graphs, and the first thing we're going to start looking at is changing our amplitude. Okay, now the thing that you're going to need to remember first of all is what the sine and what the cos graph looks like. So over on the left hand side, again, excuse my writing, sine graph starts at 0, goes up to 1, crosses at 180, back down to -1, and then back up to 0 there. Okay, so there's your basic sine graph here. And again, as I said, crossing there at 180, finishing at 360, and everything's symmetrical. So that's your y equals sine of x. And we can do the same for cos. So cos, similar idea, but it starts up here at 1, goes down to -1 at 180, and then it comes back up to +1 at 360. So at that point there, at its lowest, it's 180. And then here it's at 360. Now you need to remember those, okay? Because essentially everything we're now going to do is essentially a manipulation of those two basic graphs. There is one other one, and we're not going to look at it for this video, and I'll explain why at the end, but it will come in later on. Now, let's look at changing the amplitude. So the difference here is this A at the front has been changed to a 4. Now, I always teach it as a certain strategy when we start with these questions. And we need to try and get out as much information as we can from the question. So that 4 tells me that my amplitude is 4. And then the sine part tells me that my graph is going to start at 0, up to 1, -1, and then back to 0. And that's all the information that this function's telling me. Okay, so that amplitude being 4 means that it's going to go up to 4 and down to -4. I should say this in more detail. It tells me that from wherever it's starting, okay, so this is starting at 0, it's going to go up to 4, and it's going to go down to -4, okay, because later on in another video we'll look at changing where we're starting. But at the moment, okay, that amplitude tells you from where you're starting, how far up you're going to go, and how far down you're going to go with your sine graph. And the sine graph is going to look like this. So I'm going to start at 0, I'm going to go up to 1, down, back through 0 to -1, and then back up to 0. And again, halfway is 180, full length is 360, halfway between 180 and 360 is 270, and halfway between 0 and 180 is 90. And they're all your key points, okay? So now, whenever I'm working these, I always go through this same method every time. So I'm always looking to see what the amplitude is first. I normally work left to right. I identify the shapes, that's the sine graph, so going up and down. I make a quick little sketch, and then I label it. Okay, so make sure you're putting your 4 on, make sure you're putting the -4, labeling at least 180 and 360. Okay, it is good to have the 90 and the 270 there as well, as long as you're showing where it's crossing this x-axis though. Now, just like the usual structures of these videos, I've got one on the right-hand side. So pause the video, take as long as you need to try it, and then press play to see how you go on. Right, let's take a look at your one. Now, working left to right, I've got an amplitude of 3. And I know that it's a cos graph. So the cos graph, I know, starts at the highest point, goes down to the lowest, and then back up to the highest. Okay, so there's my shape. Now, a cos graph is slightly different. Apologies, I don't know why it's jumping around like that. Cos graph is slightly different, okay, because it's not starting here at 0. It normally starts at 1. But with the amplitude being 3, it's not starting at 1, it's starting at +3. And then it's going to go down, normally to -1, but because the amplitude is 3, it's going to go down to -3. And then I've got my normal cos graph shape. So down and then back up. Okay, it doesn't need to be perfect, okay, it just needs to roughly resemble it. Now again, the full length is 360, so halfway is going to be 180, and then a quarter the way in here where it's crossing is 270, and then a quarter in here where it's crossing again is 90. Now, that's essentially it for the amplitude. However, there is one other thing that they might do. Now, the difference here is there is a negative in front of my 2, okay? So if I can get my highlighter back, that negative changes things slightly, okay? First of all, though, I'm going to pretend like it's not there, and I'm going to answer the question in the same way. So essentially, my amplitude's 2. Okay, so it will be 2 and minus 2. That's not going to change. And I've got a sine graph. So it's going to do that. Now, essentially, that's most of it, but that negative does change something. And what it does is it turns everything upside down. Okay, so your sine graph, the 2 is going to stay the same because 2 would go to minus 2. But your sine graph, instead of starting in the middle and going up the way, it's going to start in the middle and it's going to go down the way. And then it's going to go back up the top and then back to the start. So it flips it around the x-axis. Okay, and that's what that negative does. So it's going to go down, back up to the top, and then back to 0. Okay, and again, 360, halfway is 180, midpoint is 270, and then a quarter way is 90. Now, I've got one for you to try. So again, pause the video, take as long as you need to try and work through it, and then press play to see how you get on. Now, this one, very similar to the one on the left, except I picked a much bigger number. And very often that confuses students because they think they need to make a much bigger graph. You don't need to, okay? It's only a sketch. So the amplitude is still the same, it's 15. The sine graph tells me it's going to go up and then down. But again, that negative there reminds me that I'm going to go down first and then back up. So amplitude is 15, so up here is 15, down here is minus 15. And I'm going to go down first, back up. Now, one thing you should do is show that you're clearly hitting 15. So I've not quite gone close enough there. So what I would do is I would just draw it again and just show that I'm clearly hitting that 15 line. And then 360, 180, 270, and 90. Now again, you'll notice that this one here is a lot longer than the one I did on the left. That's fine, as long as you're annotating it correctly. So 360 is a full length, 180 is halfway, 270 is 3/4, and 90 is a quarter of that length there. Now, I alluded to the fact that there is one other graph we need to draw, but it's not one that comes up too much with amplitude. Okay, it tends actually not to come up too much with trig graphs, but nevertheless, just in case. That graph is tan of x. Now, you'll know that tan of x starts at 0 and it goes up infinitely high, and then it reaches an asymptote at 90. So it reaches a point where it's both positive infinity and negative infinity at the same time. And it reappears back down here and it comes back to 0. And then it goes back up again and we get another asymptote and then finishes back at 0 at 360, 180, and 270. So it actually repeats itself twice in this 360. So once is there, and then the second iteration of the tan graph is here. So it is a trickier one to remember, and we'll come on to it in the next video. But because we were dealing with amplitude, it doesn't affect the tan graph as much as what it affects the sine and cos. Because the tan graph is going to positive infinity and negative infinity, if you increase the amplitude, you're just changing the steepness and how quickly it gets there. Okay, you're not changing what it's going to reach. So in terms of sketching it, it doesn't really apply. So when we're looking at the amplitude, we're mainly looking at sine and cosine as we saw before. Okay, right. If you want to watch the next video, that will contain some that we are looking at changing the number of reps there are.